All right, so today we are going to talk about angles. Right, let's write that. Angles. Right, we're continuing on in our geometric understanding of the world. Now, we talked a little bit about vocabulary, but the main purpose of math is to solve problems. And so we will be solving problems that involve our basic understanding of mathematical computations and geometric ideas involving, once again, angles, right? You know, you'll see some notation that looks like this, perhaps at times, right? You may see something where it looks like this, right? All the same thing. So let's dive on in a little bit further. Okay, let's first refresh our understanding as to what angles even are. Angles are simply a measure. I'll write that down. It's a key word, guys. Measure of the amount of space that that is created when two lines intersect. Now you don't necessarily have to write all that down, but just understand what it is, right? What it is, right? Let's imagine two lines here. These two lines are intersecting. There's some space going on here, right here, right? There's some space here in between the two lines, okay? Same on this side, right? There's some space here. Now that's the measure. Measure is the angle, right? It's just, that's the word that we humans have chose to denote the measure of that space. Now the measurement is what you may be a little bit more familiar with, and that is simply degrees. Degrees, right? The number value. Degrees. There we go. That's the number value of that space. Now again, once again, let me remind you that to a bird flying above us overhead, we look like nothing more than a dot, right? And so all if we're looking off in this direction and we start looking off in this direction, right? And then we suddenly avert our gaze into this direction, right? Imagine this is like a permanent line that stays in place. We avert our gaze in that direction, and then let's say we avert it back over this way, over this way, over this way, etc., etc. We go all the way around in a circle, right? That's the idea. Humans devised the idea of angles to measure space around a fixed object or a fixed point, which is what we would be again to a bird flying above us overhead. But I digress, okay? The main point here is to solve problems involving angles. So let's refresh our memory as to what some of the basic angle relationships are. You're going to see a lot of this on your homework. You're going to see a lot of this on your quizzes, but you have to be able to, at a glance, recognize the sort of angle relationship you're working with, because the angle relationship that you are working with is going to give you some clues about how to solve the problem, create an equation, so forth and so on. So let's talk about a couple of them. Complementary and supplementary. You'll often see something like this, right? This here, you've got two rays here, right, in the form of they're just kind of intersecting right there at the vertex or the corner, right? But then you'll also see this little box here. Now, just in case you aren't aware, when you see those little boxes, just know that, right, we're just saying that they're 90 degrees in math. That's all, right? So the way you read this when you first look at it is to say, okay, so all of this space here is 90 degrees. Now, a complementary angle, you'll see this a lot on your homeworks and such, is when, yes, you do have a 90-degree angle, but it's split up into two separate angles. Two separate angles, right? And if we knew we started with 90 and we split it up into two separate angles, we therefore can say something to the effect of, let's call this angle A and call this angle B. We can say something to the effect of A plus B equals 90, right? Again, we started off knowing that it was 90. We just split it up into two different parts. Right now, as we're just talking about this with no problems at hand, we don't know what A and B are. But if we knew one or the other, we could figure out what the other one was. That's what you'll be doing in your assignments. Again, I'll write this down. So it's sticks complementary, right? That's a complementary angle. So let's say that now I'm saying angle A is actually 30 degrees. You'll see a problem like that on your homework. So let's go back to our equation here. We know, we're saying that A is 30. And we're saying that A plus B equals 90. Well, we can plug this 30 back into the original equation. So now we have, right, 30 plus whatever B is at this moment, we don't know, equals 90. We didn't change anything else. It's still a true statement. Problems will say, hey, let's solve for B. Okay, well, we know from our basic equation solving skills and practice we've done on that, that simply just get rid of this 30. To do so, we subtract it away, right? This 30 is being added to B on this side of the equation, this side here, right? So we just subtract it away, but anything we do to one side, we have to do to both, right? So this becomes 0. This we're just bringing down. We didn't do anything with it. We still have the equal sign there. That doesn't change. 90 minus 30. Well, if you do the math on that, that becomes 60. So the answer to the problem is B equals 60 degrees. That's how you solve a complementary angle sort of a problem. Let's talk about another one you'll see quite often. Another one you will see quite often is what is known as, draw this real quick. Okay, you'll see something that is known as supplementary. I'll even write that down real quick. All right, supplementary. Very similar to a complementary, although okay, but you have to understand that the key difference here is that while a complementary measures 90 degrees, supplementary measures, where let's say this is A again, we'll say this is B, this whole thing, we're saying this whole thing, we're saying A plus B equals something. In a supplementary situation, you'll see it often written similar to this. We're saying A plus B equals 180, right? It's a 180 degree angle split up into two. It can look like this. It could even, it could even be straight up. It could be any sort of combination of just two angles, right? So once again, if I were to say, or the problem were to say, okay, let's say B this time is 50 degrees. 50 degrees, okay, so we'll plug that right back in. We know B is 50. We know A plus B equals 180. Okay, put B in, bam, A plus 50 equals 180. This 50 is being added to this side of the equation. It's being added to the A, so let's just get rid of it. Let's just get rid of that thing. We don't like it there. Right, boom. We still have our A that comes down. We didn't do anything with it. Can't forget about it. This becomes 0. The equal sign is still there. It doesn't change. 180 minus 50. That's 130, guys. So what we're saying here is that A is 130. And we solved that problem. That's all you do for that sort of thing. Couple more here, angle relationships that are important to know. All right, guys, you'll see oftentimes something that looks like this on a problem, or even right, it may just be fully enclosed like this, but you have to recognize what this is. What this is a vertical angle. Now, there's something unique about vertical angles. It's the idea that, I'll work on this one here for a second. It's the idea that when you have two lines that cross like this, a vertical angle is saying that these two are the opposites of one another. These two are the opposites of one another. You can almost sort of imagine it, if it helps, as thinking of this line here, cutting that picture in half, and it's basically a reflection. A reflection. Think about when you're standing in front of the mirror. Yes, you're staring into the mirror, but everything around you doesn't change, right? Your hand is your hand. The size of your hand is your hand, right? So you can kind of sort of think of this as a reflection, if that helps you. With that in mind, if we were to say, we got our A and B again, if the problem were to say, this here is 50. Well, we know it's a reflection. We know just by our definition of vertical angles, the basic idea here is saying that A is also 50. A is also 50, right? They're just reflections. Again, you look in the mirror, your head doesn't change and contort and become bigger or smaller. It is what it is, right? That's the idea. So there's not a whole lot of calculation here. The answer is simply A equals 50. Now let's say, that's a little easier, right? Let's say here that, let's erase that here. Let's expand on this idea. You may get something like this, where it's not simply just one letter. Maybe it's 2x. Well, same idea. Let's create an equation, right? 2x equals 50. You see, just because this goes from a single letter to, a 2x, or even something more complicated like, let's say 2x plus 2, just because this side can take many different forms, doesn't negate the idea that this side here is going to be equal to this side here. And the same applies to this one here, right? They're opposites. In that specific case, you can imagine the reflection or the mirror going this way. But anyways, right, now we just solve. We figured out what x is. We're saying 25. Okay, we know how to solve equations. Now let's bring our 2x back. So if we're saying that x is 25, plug this thing back into here to get our angle. 2 times 25. Well, that is indeed 50. And when you work that out, you get the 50, and you'll notice that 50 equals 50. It's a statement of truth. That doesn't change. So when you see problems like that, don't be intimidated. Just know the basic idea behind a vertical angle, and you'll be set. Got a few more here. Let's talk about something that isn't necessarily hard, but can be confusing if you've never seen it before. Okay, so you'll see problems that look very similar to this. Imagine, I know my drawings are not quite straight, but imagine these are two parallel lines. Right here's the little parallel line symbol. Okay, these mean that they're perfectly straight. You'll see a transversal or a line intersect, and when a transversal or a line intersects two other lines that run parallel to it, a unique property emerges. A unique property emerges in that some of these angles are going to be the exact same measurement as the other. Within this little diagram here, we can understand the idea of alternate exterior angles, alternate interior angles, and even corresponding angles, which I won't give you anything related to the corresponding angles, right? But what does all this mean? What does all this mean? All right, so let's break each one down. Let me write these down actually real quick. Alternates, we'll go one by one. Alternates, interior angles, there we go. Sorry for the handwriting. Okay, alternate interior angles, right? So keywords to note: alternate and interior. Interior meaning that angles between these two between these two parallel lines. They're inside of these parallel lines. So it could be this one, it could be this one, it could be this one, it could be this one. Those are all the angles we're talking about. There's no other angles to talk about. Those are the only angles that appear in between those two parallel lines. So that's the first thing to understand here. Now, along the same idea, alternate exterior angles, well, think of the word alternate, right? These aren't alternate. They're not switching it up, right? And even visually, you can see that this looks a little bigger than this one. What you have to understand is that alternate means this, right? They're kind of flipping a little bit. I wouldn't quite say it's a reflection, but they're kind of just flipping, right? They're alternating the side of the transversal that they appear along, right? So these, and even visually, once again, you can kind of deduce that these look very same. That should be a clue right here. So if we were to say this is A, and we're also to further say that A is, let's say, 40. Well, again, the idea of alternate interior angles, this unique property here, is saying that this here, and let's call this B. What we're saying is that because A and B are the same, B must therefore also equal 40, right? If B equals A, B, which we don't know, but we do know A, that's 40, then here's what we have. B equals 40. You'll need to understand that for one, but also the problems aren't going to be that easy, guys. Okay, they're not going to be that easy. Let's say let's leave the 40 there, and let's say that this is, well, we can say 2x once again. Right, 2x equals 40. All right, divide 2, x equals 20. Plug 20 back in to x. Therefore, 2 times 20 equals 40, which makes sense because why? We're saying this is 40, and we said earlier this is 40, and we're saying that this is always going to be the same as this. Things are checking out. Things are making sense. But it may not be easy. You may get something a little bit more complicated, just like Just like with the vertical angles, you may get something just slightly more complicated where instead of just 2x, maybe it's 2x plus 2, right? So you'll set up your equation. You will set up your equation, 2x plus 2 equals 40. Solve for x, minus 2, minus 2, 2x equals 38. And we're saying that, let's see, we're saying that, what's 2 divided by 38? It's 18, right? 18? Let's see here. Yeah, or 19, sorry, 19. Right, 19. Well, we take this 19, we plug it back into there. 2 times 19 plus 2, what does that come out to be? Let's see, 2 times 19 is, what is that, 38, right? 38, 38, 38. Wait, something went off here. Let's see, minus 2, 38, 19, 19 times 2 plus 2. Okay. I've got to double check this a little bit, but you get the idea, right? It's very similar to the vertical angles that we just talked about. Let's move on here. I've got to erase this a little bit. All right. Oh, messed up my transversal. All right. All right. Anyways. So, and then the other idea, one of the other big ones you'll see on your quiz, on your homework, alternate exterior angles, right? Very similar. The only difference is just the word here. If we're saying before that interior means inside these parallel lines, then, well, it would be logical to say that we're saying that the angles, with the word exterior, we're saying that the angles outside of. So anything outside of these parallel lines, right? So for example, this one's out there, this one's out there, this one's out there, and this one out there. Very similar idea. In fact, it's the exact same idea, just a different location. You can even kind of see, just like before, that these are on alternate sides of the transversal, and visually they sort of appear the same. In a problem, you'll find out in reality, and in problems, you'll see that that is also the case, right? You'll be given one, asked to solve for the other, right? You'll say, they look the same. I recognize they're alternate exterior angles. You'll say x equals 50. Again, you can say this is 2x, 2x equals 50, right? You end up getting 25, 25. Plug that 25 back in there. 2 times 25 equals 50. 50 does in fact equal 50. Everything checks out. This 50 is the same as this one, and this one, and this one. They all check out. Everything's good, right? So understand that. Understand that. You won't get problems too much more complicated than that. You may get a 2x plus 2 once again. You may get something along those lines. But understand, no matter what this says, it can be x plus 2 plus 3 plus whatever. It's all the same. Put all of this, right? Put all this here on one side of an equation. Put it equal to 50 and just solve the equation like you typically would. Solve for x. Now let's talk about angles a little bit more. There's one last little bit about angles that you have to know, and that is triangle angles, the angles of a triangle. So, I'll do, um, let's see, angles of a triangle. Again, apologize for the sloppy handwriting. All right, anyways. Well, you see, when you take a bunch of lines and you cross them all together, like what we've been working on, right, you'll see that, wait a minute, this forms a triangle here, right? That's kind of how shapes are formed, right? Everything is formed by the intersection of lines, even our own alphabets, right? The letter E, just a bunch of lines. The letter X, just a bunch of lines, right? Everything's just a bunch of lines crossing in a certain configuration. That is the same with shapes, right? So when you think about how a triangle, now you're not going to see it like this, really. You're just going to see it, kind of like this, right? Oh, you're not going to see the rays extended beyond their corners, like in here, right? You're going to see it very much like this on your paper. But it's the idea here that how do we, like, triangles, all the angles, right? There's three angles in a triangle, right? Three, one, two, three, one, two, three. Tri, it's in the word. Tri, meaning three, right? Angle, meaning three, right? One, two, three. Well, it's the idea that all of the angles, so we'll call this x, y, and z. It's the idea that if you do x plus y plus z, all of that equals to 180 degrees. Now you'll learn why that is the case as you progress in your mathematical journey in life, right? We're not going to get into that too much here now, but you have to sort of take it in, internalize it, that all three angles of a triangle, no matter the shape of the triangle, right? It could look really big like that one. It could look like this one. Doesn't matter what it looks like. The same holds true no matter what. That all three together, added together, are 180. That's useful to know. That's useful to know because much like those angle problems with the rays, individual rays, you'll have triangle angle problems where, let's pretend this is a 90-degree angle. Here we're saying that's 90. We're saying that this is 30. And we're saying this. We don't know what this is, right? So by what I just said, x, that's one of those angles, plus 30, that's the 30, plus this 90. We're saying it equals, we're saying it equals 180 degrees, 180 degrees. So combine like terms to begin solving, right? 90 plus 30, bring down the x here. So 90 plus 30 is plus 120. Bring this down again. We didn't do nothing with it. Get rid of this 120. And what we're saying here is that 60. We're saying x is 60. Well, think about it here. 60 plus 30. That's 90. I'll even write it out, right? 60 plus 30 plus 90, right? Those are all, if we're saying x is 60, then we're also saying that 30, which is given to us, plus 90, plus what we now to be known as 60, all that equals 180, right? And if we work this all out, look at that, 180. It all comes out to be 180. The statement of truth is valid, right? 180 does equal 180. So you'll see some triangle angle problems just like that one. I'm going to throw a few, I don't want to say curveballs, but it's not going to be quite as simple as I made it out to be there. Once again, you'll have maybe something like x plus, I don't know, 58. Let's say, well, this is obviously not the scale, of course. This is not a scale drawing. But, we can say this one is 75. We can say this one is 54. And you, being the studious students you are, being the astute students that you are, should recognize that x plus 58, that's one side, that's one of the angles, plus the other one, 54, plus 75, all that equals 180. Solve your equation, right? Combine these few like terms together, x, you add all that up, it comes out to be 187. 187. Well, it's going to look a little weird to you at first. You wait a minute. How can that possibly be? How can that possibly be? That doesn't make a whole lot of sense to me. And I would say you're not necessarily wrong to think that, but understand what the problem really is. The problem is saying not what the angle is. What is x? What is the correct x value which will make it such that this whole thing plus this whole thing plus this whole thing is equal to 180? Well, let's continue solving for x. Whoa, okay, there we go. X. Okay, 0 equals, there we go, -7. You're going to get a negative at times. That's okay. Don't be alarmed by this idea that it's a negative. All right, because if we plug it right back into here, or here, right, what we're saying is -7 plus 58. And when we're saying that, we're saying that it's 51. That makes sense. Now, what our equation, is saying now at this point is 51 plus 54 plus 75. All that equals 180. And indeed that does, if you add all these up, right, you'll see that it indeed is true. 180 does equal 180. So the steps that we've taken are correct. Again, do not be scared when you see a negative. Wait, I did something wrong. Nope, you are on the right track. Okay? If you plug whatever you get, it's not always going to be negative, but whatever you get here, if you plug it back in and you don't get this, right? You get maybe 160 equals 180. Then yeah, something went wrong. Look at it once again. So at this time, you should have a basic understanding of how to do angle calculation problems. I hope this has been informative. I hope you've pumped up your mental muscles real good, because we got a lot more to do.